I would say that it is a happy moment for me also to interact with all of you PG and PhD students. I've been told that you are coming from different part of India, and I would also like to extend my congratulations to NIT and SERB team for organizing such event in which the theoretical knowledge is connected with industrial experience. So any knowledge without connecting with actual use case or experience with the industry is, I would say, only half learned thing which is there. So this is a great, I would say, initiative taken by SERB and NIT team to take it forward and utilize your experience, I would say, knowledge and convert into actual experience, which will further enhance your kind of clarity on thoughts and how it can be further leveraged upon and utilized for industry. So in that direction, before I go, I would say how this journey, or I would say Industry 4.0, is beneficial for industry and how this theoretical knowledge can be utilized, and what is current industry scenario in which we are living and what is expected out of all these IoT solutions, digitalization, etc. If you look at currently industry is not that conventional industry. You start with customer side because everybody is working for customer and individual profit. So that is the two aim, I would say, for any industry. So currently it's not that you are getting any demand from customer, then you start. So we start by demand forecast. So industry is now working towards what is customer expectation. Then that is also backed up by, I would say, artificial intelligence, which is used to find out what is expected customer demand. So it starts with that. Then after that, company looks at what is its inventory level, current inventory level, which can be delivered to the customer, required customer. What is location of those customers? Suppose I would give example of our industry. We have got various delivery locations, but depending upon customer, which delivery location will result into least transportation cost. So then it comes to where, from which location we need to deliver. If we need to manufacture, which is the location which can manufacture at lowest cost, what kind of quality it is required. So all these things are related with real-time tracking of entire inventory, demand, process capability, process availability, equipment availability. So it extends to that area. And finally it comes to how do you plan your raw material for manufacturing all those things. In between the industry, which is manufacturing process, comes. So where we deliberate upon what is effective cost, I would say asset utilization, what is least cost, how we can optimize the process so that we can produce at I would say highest efficiency with lowest emissions, with without any unsafe incidents. So those are priority areas for, I would say, industry, and all those initiatives in industry for Industry 4.0 is driven towards that. So these are, I would say, with this background, I will try to give you some example or glimpse of what we implement inside Tata Steel, which is connected with this IoT solutions, robotics, or Industry 4.0 solutions. So everybody must be familiar about OSI, layers of communication. So in industry, for industry purpose, we have kind of divided our different connecting levers into these 7 layers. So it starts with network, then level 1, level 2, then enterprise application, data analysis, user apps, artificial intelligence, and visualization layer. So these are, I would say, industrial way of understanding OSI layer and utilization of that layer, and finally converting into what is desired output. And the key benefit is shown here. So all these are the benefit which is expected out of these 7 layers of architecture. And how do you support? So all these things are supported by various, I would say, expert in those areas. Those people are divided into various categories. So any IoT, or I would say Industrial 4.0 solution, needs to be backed up by the people who understand that. So it's not that era that anybody can do anything. So if you want to implement those things, you need to have people who are trained on that, who has got expertise on that. Then only you can deploy all those things. And that we divide into various categories, broad categories. So we call it like infrastructure platform. So all those things come into infrastructure. Then we have got data platform. Then insights platform. So what you are doing with all those data which is coming from various plant equipment or various process or various supply chain, etc. So all those things are divided into these broad categories. So if you want to implement or I would say journey, so this is typical journey of any automation division of, or I would say automation initiative of any industry. So we established in 1992, then further we leveraged upon. Now we are trying to do more and more research work or try to invent new things which is beneficial for industry application. And so it is just depicting what are our internal process. I'll just skip through. So for any industry, again, what are strength and capabilities required which should be built up for industry? So if you look at, it should be, as I said, that the process should be optimized for highest quality, lowest cost, least energy requirement and least emission. So those are requirement. For that we build on different models which support that optimization model or optimization of process, which is called level 2 implementation. So that is basically core knowledge we apply. That depends upon first principle knowledge, of physics. Many times it depends upon data. Sometimes it depends upon data plus first principle. So all those kind of hybrid models are deployed to achieve this optimization. And for that, the type of expertise required is mentioned here. So these are the capabilities required to further build up on those. This is just a glimpse what kind of various vertical required to achieve that kind of automation. So I'll now come to some of the use case which is there for industry. So in the area of safety, if you are not able to achieve zero harm to any person, then any production is not desired. So that is the prime responsibility of any industry, and industry should work toward that. So in that area we started with various initiatives, and video analytics these days is a powerful tool which is deployed across and achieving this unsafe capturing of unsafe behavior or unsafe incidents or unsafe situations. So in that area we started during COVID. It was social distancing was one of the things which we could deploy with the use of video analytics. Then use of mask, then personal protective equipment. So those are whether adhere to or not. So those are basically very much required if you are going to industry, and industry is full of various hazards. So any hazardous process requires certain kinds of PPE to protect you. So that kind of things are deployed, and we are able to detect with our video analytics whether people are using or not. If person is walking on stairs, whether handrail or not. So those are things which we are trying to deploy. Any demarcated zone can be detected if that is hazardous zone. So we do geofencing, and we try to find out if the person is entering into a hazardous area. Those are alerts are given. Then various scrap material as an industry we use, and when it comes to inside the works, sometimes we find that it is coming along with explosive material. So we are again deployed video analytics to find out if any explosive material is coming along with the scrap, and those are taken care in advance. It could be explosive material, it could be radioactive material which can come along with scrap. So steel industry, if somebody has seen that it consists of hot metal and liquid steel of temperature of 1300 to 1700 degrees centigrade, and that sometimes due to various process abnormality or use of some kind of inferior raw material or some kind of different raw material, we land up into explosion or mild explosion. So nobody is allowed to work in that area. So conventional way of working was that people were moving in front of hazardous process, look at various process and compliance of those process, and that was conventional mindset that unless until we see it physically, we cannot run that process. So further in that area, we decided that we should stop all those things, and we have provided video wall. So now the person is able to see everything on those video wall without going in near to the hazardous process. Then again, example of steel melting area where 1600 degree temperature steel is handled, and it is handled by overhead cranes, and operator is not able to see the ladle which consists these hot metals, and by picking up those ladles there are chances that crane is not able to engage its hook to pick up those ladles. So for operator is again video feed was provided, which is kind of dynamic. As crane is moving, the feed is getting changed on real-time basis, and operator is able to visualize the entire hook arrangement, and without any mistake he can use this to avoid any material or hot metal spillage which is at 1700 degrees centigrade. Then again, in the area of remote machines, many machines which we are done now, remote operation of those machines. One of those are locos. So earlier person used to climb down and again walk at certain locations, and during that process we had separate incidents or accidents also. To avoid that, now all the locos are running through remote operations. Then this is again deployment of technology which is based on LoRaWAN. So LoRaWAN technology is used to control some of the valves which is finally sprinkling water on the yard of pellet plant. This is again in the area of environment. So we are able to do analysis on those emissions, and we can definitely say what is the plume dispersion and which location it is going to deposit or what is the effect of that. With this we can definitely control the emissions and its bad impact. In the area of mining and iron making, some of the examples like we have got pelletizing disc, so we are able to measure the green ball size, and also we can take care of control of this sizing and automate those processes so that these size of balls can be controlled automatically. So this is again example of pellet plant where we used to do a sample testing of strength of this pellet which is formed there. Now this was manual process and that was discrete, and time to time people used to take sample. Now we have installed one online machine which picks up this sample and does the strength testing online. So that has reduced this manual effort, as well as sample which was earlier could be once in a shift. Now it is every 10 minutes or 15 minutes we can take those samples and better control the process. This is again in the area of reliability example of the area of pellet plant. We have got pellet car, and availability of that car is very important, and if it breaks down, if it deteriorates in its health, we only come to know either in shutdown or in breakdown. So to avoid, we have got online scanning, and it can definitely point out which car out of maybe 150, 160 is defective, and preventive actions are taken. Again, this is process, I would say quality related thing. Sinter is made, and in which there are different size of sintering which takes place. And for blast furnace reliability, which is getting fed from sinter, we need to have a perfect size of, I would say, or definite size of sinter. So to online assessment of those sizing, we do we utilize this video feed and apply deep learning into that and finally determine the size of sinter. Then it can be controlled online. So for example, for information, sinter is, I would say, raw material for hot metal making. Hot metal is basically iron, which we call it. Again, this is level 2, and so level 2 consists of digital twin, which I said. Digital twin will consist of optimizing the entire process, which takes care of quality, which takes care of environmental norms, which takes care about fuel optimization, which takes care of energy optimization. So those are basically part of digital twin. And some cases it was very effective in controlling emission norms. Sometimes it was felt that we need capital investment of maybe 50 to 60 crores or maybe more than that to reduce that emission, which was done by only deploying these digital twins. This is again level 2 model deployed in coke ovens. So coke is also a raw material which, or I would say the input which goes into blast furnace, and there are various optimization model or level 2 model applied into coke ovens. This is one of the example which we call it Cosmos system. So it is having data science model, then it has got various ovens in which we push coke. So pushing cycle is maintained based on actual cooking time, etc. So those things are optimized through these models only. This is a, I would say, good example of how to utilize asset for achieving maximum out of it. So in this we need to basically measure the temperature of various oven top, and to do that it is and the machine which moves, it's a moving machine. So if you want to do then various, or I would say if there are 150 ovens, we need to deploy 150 parameters for that. So instead of this what we did, that we have deployed individual fiber optic cable which is running with the machine, and it is going above that battery top and getting that signal to single parameter, which is kind of acting as a and these fiber optic cables are acting as a multiplexer. So one parameter can cater to all these batteries. So utilizing only one parameter, you are able to determine temperature of multiple ovens. So that is maximum utilization of equipment. Again, this is related with reliability of oven, how to determine that oven is having some issues. So load cell deployment on tie rod, which takes care of strain and stress on those ovens. And you can do advanced planning to take down and maintain so that we do not land up into any catastrophic outage. TURI is a good example in which blast furnace, to which we blow hot air through that, which is also required for hot metal making, and there we also charge polarized coal. So how these coals are getting charged and whether it is done in efficient way or not, and any kind of other abnormalities can be also seen. The challenge is that in front of this there is hot metal. So how to see those hot metal area without getting affected by those temperatures. So it is beautifully designed, and people are able to take meaningful output out of that readings which is coming out of visuals inside the blast furnace 2 area. And many breakdowns can be avoided, and also process efficiency in terms of PCI use is achieved. This is example in which I would say still a manual process. People go and take temperature over torpedo which contains hot metal. But earlier people used to carry a big temperature lance having long trailing cable, which was safety hazard for slip trip fall. So we converted into a wireless technology, and now those things are used without any slip trip fall hazard. This is again a level 2 system which basically models the entire process, and various parameter optimization is done to achieve process efficiency. Coming back to steel making, so hot metal is finally converted into steel. So when the hot metal comes to steel making area, it is full of slags, and slag is determinant for steel quality. So it is removed, and when you are removing it is based on manual judgment how much you are removing. So to assist operator, we have deployed kind of IR camera which gives a clear picture what is leftover slag, and operator is able to take proper decision. They do not do over raking and not also under raking, because over raking is loss of hot metal, under raking is loss of quality.